Hi guys, so today we are going to graph some angles using degrees. So the first thing we're going to do is we're going to talk about some parts of an angle. So when I talk about an angle, the way we're going to graph them, we're going to graph three things. We're going to have an initial side. We're going to have what's called the terminal side, which is where it ends. And then we're also going to draw an arrow from the initial side to the terminal side that shows direction. And that's how we're going to graph our angles. Now, where we graph them is going to be in one of those four quadrants. So the way we'll figure out which quadrant it's in is we are going to use what we already know about angles. So for example, if I take this angle, if I were to go in a full circle, okay, we know how many degrees are in a full circle. There are 360 degrees in a full circle. But that line right here, we're also going to say that that's 0 degrees. So that's 0 degrees, or we could go in a full circle and make that 360 degrees. We know that a straight line is 180 degrees. Up here, in between, halfway in between those, or making a nice right angle, that's going to be our 90 degrees. And then down here at the bottom is halfway between 180 and 360, which is 270. So if you remember from some previous math classes, the way you name those quadrants, we start right here in the top right, that's quadrant 1, and then you go in the order of a C. So it's 1, 2, 3, and 4. So whenever we graph these, the angles that we graph are going to be in what's called standard form. Standard form means that the initial side of the angle is going to be on the positive x-axis, which is basically what we marked as 0 degrees. So whenever we graph these, what we're going to do is we're going to start here with our initial side, and then we'll figure out where our terminal side goes in relation to that 0 degrees. We also are going to find something called coterminal angles. So coterminal angles have the same terminal side. And we will, in order to find those, to find a coterminal angle, you're going to add a full circle. So a full circle in degrees is 360. So what we can do is we can either add or subtract 360 to get two angles that have the same terminal side, but maybe a full circle or less. So we're going to start by graphing this first angle in standard position. So my positive x-axis, that's my 0, that's my standard, my starting line. Then I'm going to find where the terminal side is going to go. So if this is 0, I'm going to move 138 degrees away. Well, it's 180 to go to a straight line, and it's 90 to go here. So 138 is going to fall somewhere in the middle. Now, it's not super important where you put it. What you really need to do is make sure that that terminal side is in the right quadrant. Then what I'm going to do is I'm just going to draw an arrow from the initial side to the terminal side to show the direction. All right, let's try the next one, 292. So we're going to start at 0, and we're going to go 90 past 180, past 270. Our terminal side would be in between 270 and 360. All right, so let's look at a few more. So negative measures just mean we go in the opposite direction. So I still start at 0. I'm going to go backwards 40 degrees this time, though. So if I'm going backwards, this would be negative 90. Well, the negative 40 is not quite there. So that's where negative 40 would be. So negative 225, again, start at 0. We're going to move this direction. So I would go past negative 90, negative 180, but not quite to negative 270. And I would end in quadrant 2. All right, 400. So this one's a little bit harder because if this is 0 and I go all the way around in a full circle, that's 360. So I'm going more than a full circle. So to figure out where this would be, I'm going to subtract a full circle to figure out where my terminal side is. So 40 degrees, that's in quadrant 1. But to show that 400 is a different angle than 40 degrees, then I'm going to show that I've made that additional full circle. So I'm going to start at that initial side, go around in a full circle, and then end at my 40 degrees. So that's how I can tell that that's a different angle than just regular old 40. All right, 520, that's also more. So we need to go ahead and subtract 360 to get that full circle. And I get 160 degrees. So 160 is between 180 and 90. So again, I'm going to go a full circle and then stop at that angle. So those angles that we're finding were what's called coterminal angles. They end in the same place. So the way that we can find some coterminal angles is we can add or subtract a full circle. So for example, 20 degrees has an infinite number of coterminal angles because I can add or subtract 360 as many times as I want to. So if I add 360, 380 and 20 degrees are the same, have the same terminal side. 20 degrees would look like this, whereas 380 would just have a different arrow. I also could subtract 360 if I wanted to and get negative 340. Negative 340 would still have this same terminal side, but I would start at 0 and go in the opposite direction. I could subtract 360 again, and I would get a negative 700. Okay, that's also the same angle. Still has the same terminal side, but I go around in a full circle in the negative direction. So all those angles have the same side. It's just a matter of which direction we're moving and how many circles we're making. So this tells us to find 2 positive and 2 negative. So there's a negative and there's a negative. There's a positive. So let's add 360 one more time and get one more positive coterminal angle. All right, let's look at this next one, 400. So again, we can add or subtract 360 as many times as I want to. What you'll notice probably, this is already more than 360. So let's go ahead and subtract 360, and I get 40 degrees. That is a positive coterminal angle. We could take 40 and we could subtract 360 again, and I would end up with a negative 320. I could subtract 360 again, and get a negative 680. I could also take 360 and add it to the original. So these are not the only answers. It just says to find 2. So we could add 360 as many times as we want to, and it's still going to end in the same place. All right, so negative 120, again, we can add or subtract 360 as many times as we want to. I'll start by subtracting so we can go ahead and get those negative ones. So negative 480, subtract 360 again, that's negative 840. Take that negative 120, and then we can add 360 to the original and get 240. And then I could add 360 to that and get 600. All right, so coterminal angles, again, they end in the same place. The other new thing we're going to look at is something called a reference angle. So a reference angle has to have 3 things true. A reference angle is positive, a reference angle is acute, and this is the important part. A reference angle is made with the terminal side in the x-axis. So what we're going to do is we're going to start by drawing this angle. So 50 degrees. 50 degrees is in quadrant 1. So our reference angle is the positive acute angle that's formed by the terminal side and the x-axis. So what I'm looking for is how much distance is in that yellow shaded part. Well, this first one's pretty easy because this is 50 degrees and this is 0. That distance in between them is 50 degrees. But let's try another one that's in a different quadrant. So 130. 130 is going to be in quadrant 2. So what I'm trying to figure out, the reference angle here is what's made with the terminal side and the x-axis. So that yellow shaded area, however much that is, that's our reference angle. So if this is 130 and this is 180, the distance between those is 50. So our reference angle here is 50 degrees. All right, let's try 220. So 220 is not quite at 270, but more than 180. The reference angle is with the terminal side and the x-axis. So I'm looking for this distance here. So these are always going to touch the x-axis. So the distance between 180 and 220, that's a distance of 40. So our reference angle is 40. All right, 705. So we first have to figure out where 705 is going to fall. So since that's more than a full circle, I'm going to find a coterminal angle, and I'm going to subtract that full circle and find that 705 is coterminal to 345. Well, 345 would end in quadrant 4. It's past 270 and not quite at 360. The reference angle here is going to be the distance between the terminal side. So that distance between those two things would be 15 degrees. So that's my reference angle. That would be the same reference angle for 700. That 705 and 345 have the same reference angle. So right now it doesn't matter that we have one circle or a full circle around because the reference angle is all we're looking for. All right, so this one was actually a typo. We already did 130. This was supposed to be a negative 30. So let's figure out where negative 30 falls. So if I'm going backwards 30 degrees, I'm right here, and I'm looking for the distance between the x-axis and that angle. So that distance, again, our reference angles are always positive. So the distance there is 30 degrees. All right, then negative 140. So I'm going to go backwards 140 degrees, which would be somewhere in here. Not quite to 180, but past 90. The reference angle is the distance between the x-axis and the terminal side. So if I went all the way backwards, this would be negative 180. But I've only gone 140. The distance between them is 40 degrees. All right, the last thing we're going to do is going to kind of set us up for what we're going to do after our test. We are going to find some trig values using these reference angles. So the directions here are a little bit confusing, but what we're going to do really isn't that difficult. What we're going to do is we're going to draw a picture for this situation. It says find the exact value of the 6 trig functions of an angle theta whose terminal side passes through the given point. So what I'm going to do is I'm going to plot the point for negative 3. So what we have is an angle whose terminal side, so here's our terminal side, goes through that point. To figure out where this theta is, that's going to be the reference angle. So I have to put theta next to the x-axis. So what I'm going to do is I'm going to turn this into a triangle with the x-axis. Okay, so whenever you do these, it has to touch the x-axis. That's where everyone tends to make mistakes on these. Then what I'm going to do is I'm going to look at my picture. Okay, it's very similar to what we did before the break, but the difference here is we can now consider positives and negatives. So over here at the top, I've gone horizontally a distance of 4. Let me not use my highlighter. There we go. I've also gone vertically down a distance of 3. So instead of just writing 3 because of the distance, I'm going to put negative 3. Well, what I could do is Pythagorean Theorem to find my missing side. The negative actually won't affect our hypotenuse because if I do a squared plus b squared equals c squared, I still get the same thing I would as if it was a positive 3 because negative 3 in parentheses squared is still 9. So I end up with a hypotenuse of 5. Once that triangle is filled in, then I can find those trig functions. So we'll start with the 3 that we're used to. So sine is opposite over hypotenuse. So opposite of theta, adjacent over theta, and then opposite over adjacent. Then we can find those reciprocals. So if you remember the reciprocals, they are cosecant, secant, and cotangent. Cosecant's the reciprocal of sine. It's hypotenuse over opposite. Secant's the reciprocal of cosine, hypotenuse over adjacent. Cotangent is adjacent over opposite. Now with the negatives, it doesn't matter where you put the negative. So remember, negative 3 over 4 is still the same value as 3 over negative 4. And that's the same value as overall a negative 3/4. So it doesn't matter where your negative is, as long as the fraction is negative, you're going to get the right answer. If you had 2 negatives, top and bottom, that would overall make that fraction. Because all 3 of these mean the same thing. Those are all a negative 0.75. Oops, negative 0.75. There we go. It doesn't matter where you put the negative, as long as the negative is somewhere on there. Okay, a negative in the top of the fraction, in front of the fraction, or in the bottom all mean the same thing. All right, if you feel comfortable, pause the video, try this last one on your own. All right, so I'm going to start by graphing negative 5, 12. So negative 5, and then all the way up to 12. Okay, we're going to draw a triangle. We're going to connect it to the x-axis. Theta is next to the x-axis. All right, so on this triangle, I went left -5 and up 12. If I do Pythagorean Theorem, that's one of your Pythagorean triples, we would get 13. The hypotenuse of these triangles is always going to be positive. Okay, your hypotenuse will always be positive. All right, then we'll just do our trig values. So sine, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. The reciprocal of sine is cosecant. Hypotenuse over opposite. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. And those are your trig ratios. All right, so what we're going to do next class is we are going to look at the same concepts, but with instead of degrees, we're going to actually start looking at what radians are.